A front-load washer extractor and a busy coin laundry can get quite a workout. One area that sees a lot of action is the door latch and lock assembly. The components involved in the latch and lock are responsible for the proper operation, safety, and continued reliability of the front-load washer. Knowing the proper operation and adjustments, as well as how to diagnose a problem, can be the most important aspects in keeping a machine safe and running. In this video, we will show how to adjust as well as diagnose electrical problems within the door lock circuitry of two different cabinet machine door configurations. This machine must be installed, adjusted, and serviced by qualified electrical maintenance personnel knowledgeable of this type of machinery. They must also be aware of the potential hazards involved. Failure to observe this warning may result in personal injury or even death and may void the product warranty. The two different cabinet machine door configurations are the button stop interlock and the pin style interlock. Let's begin with the mechanical operation of each type. On the button stop interlock version, when the door handle is closed, the latch arm engages the door closed lever. This lever operates the door closed switch, which provides circuitry to the controls. The controls power the door lock solenoid, which releases a spring-loaded push-button stop. The stop will not allow the door handle button to be pressed, effectively locking the door. The door lock micro switch is closed after the push-button stop is released and the timer cycle continues. At the end of the cycle, the door unlock solenoid is powered and the push-button stop is retracted. The spring-loaded door lock solenoid captures the push-button stop. The pin-style door lock works in a similar manner, except that when the solenoid is powered, a locking pin blocks the door latch arm from rotating. Two coils within one solenoid allow the pin to latch in an unlocked position or release to a locked position. Adjustment of the individual components that make up the door lock assembly is crucial to proper operation. Before we troubleshoot, let's make sure that the components are adjusted properly. On all door lock styles, the door latch arm should rest at the base of the door L catch. Adjusting the door hinge will provide the proper alignment. If the L catch or door latch arm are worn, they should be replaced. When the door handle is rotated to the closed position, the red door handle button will pop out. Once the door is closed, the door closed switch should remain closed regardless of handle movement. The door lock lever tab should be adjusted so that the door closed switch has continuity just as the button starts to travel outward. Adjust the nut in the center of the push button stop and door closed lever until you feel resistance, then back off 1/4 turn. The slide should move freely but have little play. The door lock micro switch should have continuity just before the push button stop is fully extended to the right, locking the door. This adjustment is crucial to the safety of the machine. The pin-style door lock is similar in adjustment, but is more sensitive to proper door latch adjustment. With the door closed, the door latch should rest at the bottom of the L catch. Apply moderate downward pressure on the handle and manually engage the pin. If the latch obstructs the movement of the pin, the door handle should be adjusted. Open the door and loosen the 3 screws that mount the handle to the door ring. The door handle set screw can be moved to the top of the handle and tightened to rotate the handle assembly counterclockwise. Retighten the 3 mounting screws and check for proper operation. Now let's look at the circuitry involving door lock and door unlock functions under normal operation. Only qualified personnel knowledgeable of electrical test procedures, test equipment, and appropriate and necessary safety precautions should attempt adjustments and troubleshooting. Always disconnect power from the machine before attempting any service procedures. For reasons of clarity, we will show line 1 voltage represented in red and neutral shown in blue. L1 and neutral potential are present elsewhere on the schematic, but we will concentrate on the circuits being discussed. Line 1 is present through the control fuse to the time delay relay and the door handle switch. When the door is closed, line 1 is present at several odd-numbered timer terminals, normally open number 1 on the door lock PC board relay, and through the door lock switch to common number 4 on the door lock PC board relay. Neutral is present at the timer delay relay, ACN, and the negative side of the capacitor. When the timer is advanced from the off increment to the start increment, 9 to 9B is closed in the timer and powers the relay on the door lock PC board through terminal ACH and ACN. 1 to 5 and 4 to 3 are now closed contacts. Line 1 charges the door lock PC board capacitor. The neutral to the capacitor is provided through a diode and thermistor. Capacitor potential of between 150 and 180 volts DC is now available to the door solenoids. The next increment on the timer is door lock. 11 to 11B closes the circuit to discharge the capacitor through the door lock solenoid. When the door lock solenoid is powered, the push button stop is released. The door lock switch closes and provides power to the timer contacts involving fill and motor circuitry. The capacitor is recharged for door unlock purposes. If the door lock switch does not operate, the timer will rapid advance to the end of the cycle. This is done through the unoperated door lock switch and relay contacts 4 to 3 on the door lock PC board. At the end of the cycle, or stop the timer contact to 9B open and the door lock PC board relay contacts return to an unoperated state. 12 to 12B in the timer closes, which completes the capacitor circuit through relay terminal 2 to 5 and the door unlock solenoid is powered. We will set an analog voltmeter on DC and place it across ACH and terminal ACN on the door lock PC board. When the cycle is started, we will see the capacitor charge, discharge to lock the door, and then immediately recharge. It will remain charged until the end of the cycle when it discharges to unlock the door. If power is lost to the time delay relay for 1 minute or more, the time delay relay will close the circuit to the door unlock solenoid and unlock the door. When power is restored, the timer will rapid advance to the end of the cycle. This is accomplished through the unoperated door lock micro switch and relay contacts 4 to 3 on the door lock PC board. The pin-style door lock uses a different door lock PC board. The capacitor on this board is only used for power failure door unlock. Rectifiers change AC line voltage to DC during normal door lock and unlock functions. Line 1 is present through the control fuse to the time delay disconnect coil and the time delay relay. Line 1 is also present at the door closed switch. When the door is closed, Line 1 is present at several odd-numbered timer terminals and terminal number 10 of the door lock PC board. Neutral is routed to the relays and is present at terminal number 5. When the timer is advanced from off to the start increment, 9B provides line 1 to terminal number 8 to charge the capacitor. 7A provides line 1 to terminal number 17. The next timer increment is door lock. 11 to 11B closes and provides line 1 voltage to the lock rectifier. This AC voltage is rectified and sent to the door lock solenoid as DC. The door lock microswitch closes and the machine will fill and tumble. When the pressure switch is satisfied, Line 1 will be routed to the reversing timer. The reversing timer powers the program timer motor every 30 seconds to increment advance through the cycle. If the door lock microswitch does not close, the timer will not rapid advance. At the end of the cycle, or stop increment, the timer closes contact 12 to 12B, which provides line 1 voltage to the unlock rectifier. This AC voltage is rectified and sent to the door unlock coil as DC. We can test lock and unlock circuits by putting a voltmeter across the AC inputs and DC outputs. For door lock, we should see AC line voltage across 12 and 5 of the PC board. This is immediately rectified to DC output on negative terminal 11 and positive terminal 13 to the lock coil. For door unlock, we should see AC line voltage across 15 and 5 and DC output on negative terminal 9 and positive terminal 14 to the unlock coil. If power is lost during the cycle, the time delay safety disconnect relay will close. After 1 minute, the time delay relay will close the circuit between number 6 and number 16 on the door lock PC board. This will discharge the capacitor, unlocking the door. In addition, the capacitor latches a relay on the board which opens relay contacts 1 to 2, removing the pressure switch circuit and closing relay contacts 17 to 18, which rapid advances the timer to the off increment when power is restored. At the off increment, 9A provides line 1 to terminal 10 to unlatch the relay. Contacts 1 to 2 are closed and 17 to 18 are open. Well, we hope this video has helped expand your knowledge of the push-button stop and pin-style door locks. Understanding their components and how to make adjustments is an important part of keeping your equipment running safely.